Hey everyone. So today we are going to talk about list collection in C#. So if you have been following the other videos that I'm doing in the C# hands-on series, so we have already covered arrays, no, which is basically it's a container, right, to hold values of the same type. So you could create an array of integer or you could create an array of strings. So, but one thing that we saw with arrays is that at compile time, you need to exactly know what's the size of an array. Okay. So for example, if I'm at compile time, if I'm already aware that I need numbers and the length of numbers, the maximum number of numbers that I want is let's say 100. So I can go ahead and create an array of 100 integers, right? So similarly, we have other collections as well. And in this video, we are going to talk about list collection, and we'll see like what's the difference between list versus arrays. And also we have another collection, which is ArrayList, right? So these three are very similar collections, but we should know like when and why we should be using one or the other. All right. Okay, so let's start. So let's first see like how we can define these collections. So I'll just quickly create an integer array, right? So integer array we have already seen before. So I'll say int array numbers equals to new int. Say I want an array of 100 integers. So this is how you define an array of 100 integers. So now what I can say is numbers of 0, because arrays are indexed from 0. Actually, all the collections, right? Usually they are indexed from 0. So I can say the first element is 3. So I'll just rename this as, I'll call it as numbers array. All right. So now, second. So now let's create an array list, right? So we'll create an array list. Array list. Let's call it as array list equals to new array list. This is the container, and if you see the basic difference between an array and an array list is, so we don't have to define the size at runtime, right? So this is the advantage that we get with array list, right? So you can put in n number of elements in the array list till your till the memory exhausts probably. Okay. But the other difference, if you've also noticed here, is we're not defining what is the type of data that we are supposed to add to this array list. In the case of integer, we are directly specifying that okay, this is an integer array, right? So all we can put inside this array is our integers. But with array list, this is not the case. So what I'll do is I'll say array list of 0. So I can put in anything here, right? So I can put in a number, but at point at index 1, I can also put in a string. We'll call it as random string, right? So now, I mean, you could think of this as an advantage, but this is also a disadvantage, right? So now let's say I have to loop through this array list. And because I'm not sure like what's the data type going to be, the data type that I would be expecting out of this array list is object, right? And then I have to manually do a explicit parse. Okay, so let's say I create a variable where number equals to array list. So let's say I already know that at 0th position, I'm going to get a number. All right. But now if you see this, the data type for this number is object, right? So we have to explicitly do a cast. I have to do a convert dot to int 32 in order to access this 0th element, right? And then convert it into a number. Now it becomes an integer. So advantage of an array list over array is that the size, there's no limitation on the size. But the disadvantage that we get here is that it's no, there's no way to define the data type. So we can put any type of data inside an array list. So we have to do an explicit cast, right, while accessing data out of an array list. So now to get benefits, no, let's combine the benefits of both arrays as well as array list, right? So and then we have a collection called as list, and this is a generic collection, right? And when we say generic collection, at compile time, you have to tell the compiler that what kind of data would you be putting inside this collection. So here, so let's say I want to create a list, but the list has to be of numbers list equals to new list end. Okay, so if you see here that I'm not defining the size of this list, so it has the advantage of limitless size of array list, but at the same time, it also has the benefit of what we get it from arrays, right? That at compile time, we are defining what's the data type of the elements that are going inside this list. So now I can say numbers list or 0th position, I can say 4. And on first position, if I try adding in a string here, blah blah blah, whatever, it will give me an error at compile. It should actually give me an error at compile time, right? So it says that represents a sequence, blah blah blah, cannot implicitly convert type string to integer. So it has to be, it enforces that on compile time, right? And if you try to access this, yeah, at runtime, any of the element or loop through this list, the compiler already knows that the data type that's stored inside this list is going to be of type integer. And so you don't have to do an explicit cast, right? Conversion here, there's no need of the conversion, like we have to do it in ArrayList. Okay, so let's quickly see what all methods do we have on the list class or list collection. Right, so the first important method that we need to understand is the add method. So add simply, I know there's only one overload here, and the type of this data type would depend on the type that you have specified here while defining your list, right? So in this case, you can add any element using add method. What you can also do is there's a very handy method. So it's called AddRange, and it takes in an IEnumerable collection. And because arrays are also enumerable, what I can do is I can just say numbers array, right? So it would actually loop through all of the elements of arrays and add all of these array elements to this list collection, right? So very, very handy. So you don't have to do an explicit for loop and then check each of the element and then put it in the list, right? So you can just use add range. So let's see what all methods do we have. So we have the count method. It's not a method, it's actually a property. It would just give you the count of elements inside the list. Right, so add and add range we have already seen. So there's also a method called as tool array. So if you want to convert your list to an array of integers, and sometimes you have to do this because you have to pass an array or do some processing on the array. And no, probably the other methods that you were working, the legacy method were working with arrays. Right, so there could be a number of ways why you want to convert a list to a array, right? Okay, so let's quickly, yeah, so there are a lot of methods here. If you see like find and find all, find last, which actually takes in a predicate. And we have not talked about predicates, and we did touch on delegates in the last class. So predicate is one example of an inbuilt delegate in C#, and probably we'll have another session covering the inbuilt delegates in C#. But think about predicate is like a method pointer, right? A method which, given an input, just says that okay, the condition is true or false, right? So that's the whole point of a predicate method, right? Or a predicate delegate. So we have for each is anyways, right? So you want to loop through all of the elements. You can also get index of certain elements inside a list. So you want to see that, for example, in a list of numbers and integers, what's the index of let's say 5, right? So if it's available in that list, it would give you the index of that particular element. Otherwise, it would give you -1. So you can go through the entire list. It's available on docs as well. But that's the whole point of using list. It gives you the advantage of infinite size, and it also gives you the advantage of it being generic, that it's you define at compile time what's the type of data that you want to store in a list, right? So that's all I wanted to cover in this video. Thank you for watching, and I'll see you in the next video.